In Chapter 3, we're going to continue to work with this idea of exponents. So we've been working with different polynomials that are at different degrees, which involves the variable being at different powers. Now we're going to work a little bit with exponents. So the key element you need to be able to, learning objectives for this, the key elements you need to learn are how do you evaluate nth roots and how do you use rational exponents. Vocabulary is going to be the nth root of a, and in this case, if you wrote this out, nth root of a would look like this. So this is a root, right? You're used to a square root. Now we're going to work out with roots of different, essentially different powers, but n here is the index of the radical, and then a is, of course, the radicand, which you've already learned. So this is how you would write the nth root of a, and n, which is essentially the degree of the radical, is called the index. Okay, a problem that you might need these skills to solve would be this one from a concept of biology, where we've got an equation here that allows us to find the length of a coral cod based on knowing its weight, or we could find its weight based on knowing its length, either way. And in this particular problem, they want us to find the length of a coral cod that weighs 200 grams. So they've given us the weight, and we're going to find the length. But before we get to that, let's take a look at some of the new information here. So we're going to talk about some things. This is really the review of the nth roots of a are things that you're familiar with already, and they're based on looking at the index and the radicand, which we've done in the past. So when a is less than 0, meaning when my radicand is a negative number, there are no real nth roots when the index is even. So a square root, a fourth root, a sixth root. However, if it is a negative number and it has an odd index, third root, fifth root, then there is actually a single solution. Okay, when a is equal to 0, the index is equal to 0, there is one real nth root, and that is 0. And it's the same when my index is odd. So even and odd, that one makes no difference. And when my index is even and my radicand is greater than 0, it's a positive number, then I have two real nth roots. Whereas if it was an odd index, then I would have only one real nth root. And this is similar to what you found in terms of solving by taking square roots, solving by taking cube roots. We've already sort of discussed this idea. Okay, if I want to find nth roots, my index is 3. I'm looking for the cube root of negative 27. I have an odd index and a negative number, so I'm going to have a negative result. And the cube root of 27 is 3. So this would be negative 3. And the reason for that is negative 3 times negative 3 times negative 3. Right? Again, a quick review here. I'm saying that negative 27 is negative 3 cubed. That's what brings the negative 3 out. When the index and the power match, then it brings the radicand out. Okay, so negative 3 times negative 3 would be 9. Times negative 3 is negative 27. That's just to sort of verify that for you. Okay, when we're looking for the square root, right? When it's a square root, we don't write the index, it's assumed, of 64. That would be plus and minus 8. Okay, because this is the square root of 8 squared, right? An implied index of 2, and that's what brings that out. Okay, now go ahead and do a little practice. Do problems 18 through 20, and then come on back to the lecture. So here's a new piece of information, and this is going to allow us to take things we've already learned with the properties of exponents and apply them when we've got roots and or a mix of powers and roots. So when we take a look at this, what we're basically saying is that let a to the 1 over n be the nth root of a, right? And m be a positive integer, then we're saying a to the m divided by n power is equal to a to the 1 over n power to the m power. So this is taking the power property where I've got a power being taken to a higher power. I multiply the exponents, right? You can see that m times 1 over n will give you m over n. And we're saying that a to the 1 over n is the nth root of a. So then we're going to have the nth root of a to the m power. Okay, well, what does this really do for me? What this basically says is that if I have roots and powers put together in a single problem, I can take the index of the root and make it the denominator of a fraction, and take the power, the exponent, and make it the numerator in a fraction, and now I can write my whole expression here as a power with an exponent that is a fraction. Okay, and then this is just basically the property of negative exponents. We already know that a to the minus m over n would be equal to 1 over a to the m over n, and you can see that then this whole item is just going to move right down to the denominator. So just keep in mind that the concept of a radical being negative is an entirely different idea than what we're talking about here, with denominator being a root and the numerator being a power. Okay, so some practice on that. If I want to evaluate this expression, this is going to be the third root of 8 to the first power. The third root of 8 is 2. 2 to the first power would be equal to 2. So if we take a look at this, this is maybe a little more complicated. We have 1 over, and then I want to get rid of the negative exponent. So this would be 1 over 81 to the 3/4 power. So I inverted this denominator and then made the exponent be positive. When I invert and multiply, this will just end up being 81 to the 3/4 power. So that's the fourth root of 81 cubed, right? So if I look at 81 and think about, well, what to the 4th power makes 81? Well, that's 3 to the 4th power. This is going to cancel that, and I'll just get 3 to the 3rd power, which is equal to 27. Okay, so you go ahead and practice this. Do problems 25 and 26, and then come on back. Now, a nice part about putting a combination of roots and powers into what's called a rational exponent, so an exponent that is a fraction, is it allows us to very quickly do multiple operations at the same time with our calculator. So if I want to do 9 to the 1/5 power, I want to make sure you use this correctly. I'll do 9 up caret, open parentheses, 1 divided by 5, close parentheses. The key here is, if you're going to put a fraction exponent into your calculator, you must use parentheses. If I put 9 up caret 1 divided by 5 without parentheses, what I've told my calculator to do is take 9 to the 1st power and then divide it by 5. So 9 to the 1st power is 9. And this is what the calculator will do, right? Which is very different than what we're asking it to do. So it would have to be 9 up caret, open parentheses, 1 divided by 5, and then enter in order to get the correct answer. Okay, so that's really the key element you need here, right? Is that when you put a rational exponent that is a fraction into your calculator, you must put parentheses around it. Okay, so practice doing that on problems 38 through 40. And then some problems using these sorts of properties. So again, when I have x to a power, I want to isolate that. So in this case, I would divide by 5. 1080 divided by 5. Let me just go ahead and do that with long division here really quick. So this is 216. So x cubed is equal to 216. So then x will be equal to the third root of 216. So again, how do I solve for x when I have a x to the third power? Remember, when the power of the root and the power of the exponent match, then I just get the radicand. So in this case, x would be equal to 6. Right? Again, I would want to isolate the root. X to the 6th power would be equal to 100 minus 36, which would be 64. X is going to be equal to the 6th root of 64. And in that case, that's going to be plus or minus 2. Okay, so you practice this work. Go ahead and do problems 38 through 40. Oops, I'm sorry. So you practice this work. Go ahead and do problems 53 through 55, and then we'll solve the problem about the cod. So if you remember, we looked at this earlier at the beginning of the lecture. I've got a formula that has two variables, weight and length. And then this formula that relates weight and length of this type of fish, the coral cod. They have supplied me with the weight. So if I plug the weight in, then what I would do is divide by this 0.0167. 200 divided by 0.0167. That's basically equal to 11,976. And then I would find the length of the fish by taking the cube root of that number. And I went ahead and did that in a calculator. And it's basically 22.88 is equal to length in centimeters. Right? So again, I know I have a single answer. That makes sense, right? I wouldn't have, right? If this had been an even root, I would have gotten a positive and negative number out of that. A fish can't really have a negative length, right? But because this was an odd root, I knew that there was a single solution. If it had been an even root, there would have been two. So this is working with properties of exponents. Mostly this should have all been review for you, and I'll see you in 3.2.